Our next set of figures that we'll be talking about are triangles and trapezoids, and you'll see how they are related with their formulas. So, just to review, perimeter and area. Perimeter is the distance around the figure. Now, we don't have to do specific examples for these two figures. You just simply add the distances, the measurements of each of the sides of the figures. So, it's the area that sometimes gets a little complicated. So let's first talk about the triangle. And the formula for the area of a triangle is 1/2 times the base times the height. So 1/2 BH. The B, it stands for the base. So you can just say that's the bottom. Okay, but you can really designate any side of the triangle as a base. I'm not too worried about that. Then the height, we have to be careful what the height is. It isn't necessarily one of the other sides. We have to take from the base the opposite vertex, and we draw a perpendicular line to the base. It has to be perpendicular. This dotted line, the length of that is the height. So let's just think about for a moment, if we had a base of 5 and a height of 4, what is the area of that triangle? So if area is 1/2 base times height, the base is 5 and the height is 4. So 1/2 times 5 times 4. And you could punch that into your calculator if you wanted to, but remember that multiplication is, you can just mix them up. You can associate them differently. So I can say, I can mix this up. This is 5 times 4 is 20 times 1/2, and I get 10 square units. Remember that area is always in square units. So we have to be also careful because we have different kinds of triangles. What if we had a right triangle? So here is our base, and since this is already a right angle, this becomes our height. So we don't have to draw up a separate height. Then you might have an obtuse triangle. Let's say you had this. This would be our base. Now remember that the height is a perpendicular line that goes from the base to the opposite vertex. But we really can't draw a dotted line and make that a right angle. And if we just simply drew a dotted line there, it doesn't go to the vertex. So what we do is we take this vertex, drop a perpendicular line. We have to extend this base out. So here would be our height. This should have been a B. So our base is this side, and then our height is this imaginary length. We still can do area equals 1/2 base times height. Now, trapezoids. Just a reminder of what a trapezoid is. It has one set of parallel lines, and they are not necessarily congruent. So, we also have a height. Remember, it is a parallel line to one of the bases. So what these bases are, we label them B1 and B2. The parallel lines are both bases. And remember that the perimeter is simply the distance around, but the area. Now this is where you can see that there are some triangles in here. It's kind of, it might be related to a triangle. So we start off the same way. 1/2, just like this. And then instead of the base, we have two bases. So we are going to add them together. B1 plus B2, and we multiply it by the height. So this is why we discuss these together, because the formulas are nearly identical. Here you have one base, and here you're adding two bases together. So let's do an example. What happens if base 1 would be 8, base 2 would be 4, and say say my height is 3. So if I use this formula, area equals 1/2, I'm going to add the two bases together, 8 plus 4, and then multiply it times the height. So now I will simplify that. 8 plus 4 is 12. So 1/2 times 12 is 6 times 3, and that is 18 square units. Now, some trapezoids may look a little bit different. Remember that trapezoids have one set of parallel lines. One of your sides could already be at a right angle. If this is the case, this is your B1, this is your B2, this then becomes your height. So if it's a right angle, this is your height, that's what you'll use for H. If these are not right angles, and a lot of times they're not, you have to have a separate height. You have to imagine that. That's why I put the dotted line in there. So there is your introduction to triangles and trapezoids. Those are related figures. Now go practice.